It's been a really long time since I made a dedicated Xenoblade X video, and it's also been a pretty long time since I made a science video. So I figured, since I've got an astrophysics final tomorrow, why not pretend I'm studying for that, and make a video talking about the science of planet Mira, and basically trying to figure out where it is in the universe, as well as seeing what I can find out about its solar system. Now, obviously, a lot of things about Mira remain a mystery even throughout the end of the game, and while I won't be going into any sort of story spoilers, I am going to have to assume that everything you see as a character in the game is everything as it is. There are plenty of theories about how Mira is actually a simulation or purgatory or something, but for the purposes of this video, instead of just being, oh, it's Mira, the planet is weird, so you can't make any observations about it, I'll be assuming that the planet itself is a normal physics-abiding body, and all the weird stuff that happens is a result of some outside force. So, the night sky we see is real, the couple views of the outside of Mira we get in the opening cutscene are real, but all the wacky hijinks that go on are something not directly tied to the planet, because if I just said Mira's weird, then this video would be over right now because we wouldn't be able to explain anything. So, before we start trying to talk about what kind of planet Mira is and in what kind of solar system, I first want to try to figure out where in the universe it's located. Unfortunately, we're only given two pieces of direct information about this. The first is that it was 2 years approximately from when Earth was destroyed to when the White Whale was shot down over Mira, and the second is that the White Whale is a light-speed vessel as confirmed by a certain quote in the ending, which again I won't be talking about. Now, it says light speed, so that could mean exactly light speed or light speed bare minimum, and it might have some sort of superluminal capability. Now, the thing is, light speed travel is not a thing we think is physically possible as of now, or with current technology at the very least, so it kind of puts a bit of a wrench in things. But, of course, this is fiction, so I have no problem in saying, yeah, in this universe, that's how things work, but that means we can't necessarily use realistic approaches to try and figure some of this stuff out. A user of Steemit by the name of Scholarly Nanobot has actually already written a blog post about a year ago trying to figure out exactly how far away from Earth Mira is. And I'm going to link this article in the description, of course, always citing my sources, and you should totally read it. But while I do agree with their approach, I do have to disagree with their eventual finding. The method they used was to assume that some sort of time dilation was in effect as the result of the White Whale traveling extremely quickly. Basically, because of relativity and a bunch of stuff that I don't want to go into in too much depth because I don't even completely understand it, which means I could never explain it properly, if you're on a spaceship that's moving a significant fraction of the speed of light, time for you will appear to move slower compared to everyone else who's not traveling on the ship. Basically, since the White Whale was traveling really fast, 2 years with respect to the White Whale, as in the 2 years experienced by the crew on their trip, is probably a lot more time relative to the rest of the universe. That is, the amount of time it took the White Whale to get from Earth to Mira, as observed by, say, someone who was on Mars and didn't get destroyed with Earth, would be a lot longer than the 2 years the actual passengers on the ship experienced. They used a specific time dilation calculator, which I'll also link in the description, and basically just assumed that the White Whale would be traveling at exactly 99% of the speed of light, and eventually figured out that in the 2 years to the ship would actually have traveled approximately 14 light years. Now, like I said, I like this idea, and they actually went one step further by finding a possible candidate star that Mira could be around that's about 14 light years away. But they made the assumption that because we can't figure out how to do light speed, there's no way the fictional spaceship could do light speed. And furthermore, they put in 99% of the speed of light into the calculator, when it actually goes to like 10 decimal places, so you could just plug in 99.999999999, or the closest you could get to the actual speed of light. When I plugged in the maximum amount of 9s after 99, I got a distance in light years of more like 100 million, which is not anything remotely near us. It's actually about the size of the entire Virgo supercluster of galaxies, which is the cluster of clusters of galaxies that the cluster of galaxies the Milky Way is in. So, there's a much bigger distance scale at play here, so clearly something's amiss. since we don't know exactly if or how time dilation works for something moving at the speed of light as opposed to slightly below it, this kind of doesn't work in general, but it is a pretty cool thought experiment, and I liked seeing just how far the white whale could travel if you assumed all of this stuff would happen and it was not even moving at the speed of light. Because of this though, I have to double back on what I said and just go under the assumption that we're not talking time dilation. It took 2 years relative to the universe to get to Mira, and the whale is just capable of travel at some multiple of the speed of light. Thankfully though, there is some more information that's not directly mathematical that I can use to at least somewhat pin down where Mira actually is. I'm going to still assume that Mira is located in the Milky Way galaxy, and not outside of it, and certainly not as far away from it as something at the edge of the Virgo supercluster. Midway through the game, we learn that the Ganglion is just one arm of the Samar Federation, which is an interstellar organization that controls around 6 million light-years of space and multiple galaxies. That is completely accurate. There are plenty of galaxies within 6 million light-years of the Milky Way, or of Earth in general. And it turns out that 5 million light-years is basically the general boundary of what's considered the local group, so Samar probably has control, or at least operates in, most if not all of the galaxies of the local group, and maybe a couple outside of it. Just judging by the fact that the Ganglion is a small offshoot group focused on trying to eliminate humanity specifically, and the surprise with which the characters reacted to the general idea that Samar controlled multiple galaxies, I think it's safe to say that the Ganglion were focused on the Milky Way because humanity is from there, and that Mira is still within the Milky Way because the idea of an organization spanning multiple galaxies is a lot less surprising if you've already been to multiple galaxies. Now, it could also be in a smaller companion dwarf galaxy to the Milky Way, like one of the Magellanic Clouds, but if that were the case, you'd probably be able to see the entire Milky Way taking up a huge portion of the sky from somewhere on Mira. And while, yeah, the night sky is no different no matter where you go in the explorable portion of the planet, and that could easily be explained away by dust being in the way, or it not being a time of year where that part of Mira is pointed at the Milky Way, or that part of Mira never actually being pointed at the Milky Way, I do think it's safe to assume that it's more on the fringes of the galaxy as opposed to a different galaxy entirely. Additionally, while it doesn't look anything exactly like them, there are actually a couple clouds of stars in the night sky of Mira that bear a striking resemblance in terms of relative size and distance from one another to the Magellanic Cloud, so it could just be you're somewhere else in the Milky Way getting a different viewpoint on them. Now, if we want to try and figure out where exactly in the Milky Way the Miran solar system is, there are a few different leads we can follow. The first is that there is actually a star called Mira, which has been referenced in the Baten Kaito series, which is also made by Monolith Soft. Additionally, the star Mira is in the constellation Cetus, which is the whale. White whale. Wow, that's pretty cool. There are two problems with that, though. The first one is that Mira is actually a double star system, but you only see one star in the sky. The second is that Mira A, the bigger star in the system, is a variable red giant star, and, well, the sun we see in the Miran sky is neither variable nor red. The second star, Mira B, is a white dwarf, and that might not sound promising, but it turns out that not only can white dwarfs have habitable zones, but if you were on a planet within that zone and looked up at your star, it would actually be about the same size and color as the sun appears to us, which, yeah, that's pretty accurate to how Mira's sun appears. But if you were that close to a white dwarf, your planet would be tidally locked to it like the moon is to the Earth, and there would be permanent night and day sides, and there is a day-night cycle on Mira within the same location, so it turns out that it cannot be orbiting any white dwarf, let alone Mira B, so it's most likely orbiting a sun-like main sequence star. Unfortunately, this does very, very little to narrow down our search, because while yeah, there are millions of white dwarfs that now we know Mira can't be around, there are also millions of sun-like main sequence stars in the galaxy, so we're gonna run into plenty of trouble. It is worth noting, though, that it seems very, very likely that Mira is a single star system like the Sun, and not a binary star system. And thankfully, most star systems are actually binary, so technically we can narrow it down to less than half of all stars in the Milky Way. Unfortunately, that's basically it. There's not nearly enough other information to try and tell where exactly in the galaxy Mira's star is. I do think it's safe to assume that it's located in a region of the galaxy that's a lot less dense in terms of stars than the Sun is, either in between spiral arms or closer to the edge of the disk, and that's based on this shot we get of Mira's airspace, as well as just the general night sky that you can see. Yeah, you got the Magellanic Clouds, but beyond that, there's really not very many significant groupings of stars. Yeah, you could see tons of stars out there, and to the best of my knowledge, it doesn't appear to be a copy-paste of Earth's sky, but you don't see anything like the huge band of the Milky Way that you can from some places on Earth, and that doubly means a lot because light pollution is not a thing on Mira, while it certainly is on Earth, so you should be able to see a lot more than you can from here. Really, the biggest structures that are out there aren't star clusters of any sort, or any kind of grouping or unified structure of stars, but these multicolored gas clouds, which, yeah, those are a thing in the Milky Way. They could represent just gas and dust spewed out by something, or they could be nebulas or other regions of star formation, and they are translucent, so it's not really exactly possible to tell where they are, but they are scattered somewhat randomly around the Miran sky. Obviously, the developers just made it in a way to try to get it to look cool, but in terms of science, there's not really much that I can tell you about this. The best guess I have is that it's located in between spiral arms, so you're looking at the dense regions of star formation in two different arms when you look multiple directions, but yeah, that's really the best I can tell you. The most that I could figure out is that it's most likely orbiting a Sun-like main sequence star. So with that out of the way, we can start talking about something a bit closer to home, what type of planet Mira is, as well as its solar system. We do already know at least a little bit about the sun of the system, and we do get this very nice shot, the same shot I was talking about before, of Mira from orbit. And yeah, it looks surprisingly like Earth, so it's most likely an Earth-type rocky sort of planet that is, again, obviously located within the Goldilocks zone or habitable zone, aka the region distance from a star in which water can be liquid, because there is liquid water on its surface. We do also know that it has some sort of atmosphere, just kind of context clues by the fact that life is on it, and there are plants, and you need an atmosphere for plants, and also, if there's not an atmosphere, a lot of things will get killed by solar radiation, so we do know that much, plus you can see the glow of the atmosphere in that shot anyway, so it's pretty obvious. And also that its surface gravity is weaker than Earth's. This is confirmed by the lack of fall damage, the fact that Elma says it has less gravity than Earth, and the fact that it's able to support much bigger plants and animals. There is actually a limit to the size of terrestrial life that is directly related to the strength of our gravity, and it's also why things with skeletons can get bigger in the ocean than they ever could on land, because the buoyancy of water takes away some of the force of gravity. Life on Mira can get a lot bigger than life on Earth, so that also goes to show that gravity is significantly lower. The cool thing about planets is, a good chunk of them, like a third, actually have comparable gravity to that of Earth. Even the gas giants are within 1/10 of ours, even though Mars is closer to 60%. Unfortunately, without other data, like the mass of the planet or the radius of the planet, there's not really a way to tell how big Mira is. You'd need one of them to find the other. It's not really possible to get just from gravity less than Earth, even if we assume it has a similar density. While we could measure the acceleration due to gravity based on the size of characters and the amount of time it takes to jump, video games as a whole tend to give their fictional worlds stronger gravity than Earth, and just let the characters jump higher than they ever would be able to, and I'm sure that even with the canonical less gravity than Earth, that would still be the case for Mira. So it's not really possible to tell whether it's an Earth-sized planet, a planet smaller than Earth like a hypothetical Mars when it had an atmosphere, or a super-Earth, but we at least do know it's within the habitable zone. Additionally, it's hard to tell, but I don't think Mira has any other visible planets from it. Based on the skybox, while I can't rip the textures and I haven't seen anyone do it themselves, I'd be pretty interested in seeing that. It obviously never changes with time like an actual night sky would, and the stars don't twinkle like they should if the planet had an atmosphere, but I don't see any other bodies in the sky that are bigger than a single point of light, as would be expected from another planet. Interestingly enough, that might actually make Mira's system the norm and ours the exception, because of the almost 3,000 stars we've discovered that have confirmed planets, only about 650 of those have had more than one, and we've only ever found one other solar system that has 8 planets like ours. Every other one has had less. It's very, very possible that we just haven't been able to detect the majority of planets out there, which is extremely possible because a planet has to be in a very, very specific window of conditions in order to be visible from Earth with current methods at all, so it's extremely possible that there are just other planets around stars that we found one for that just couldn't be detected like the others. But at the same time, based on current data, that would make Mira a more typical solar system than our own. That doesn't mean the planet is alone though, because if you check the night sky, it actually has a whopping 5 moons. All 5 of them appear to be heavily based on Earth's own moon, being similar colors, all round, and just generally looking like depictions of our moon in fiction. The one thing that isn't very realistically accurate though is their size. They all appear far bigger than Earth's moon ever could be. That's just, again, a general thing in fiction to draw the moon a lot larger, but seeing as how the sun is actually pretty accurate, I do think that that's intentional and that these moons are either a lot larger than Earth's moon or a lot closer. They all seem very similar, and I think the 2 smallest ones actually do use the exact same texture, and you can get them both on screen at the same time, which makes for some pretty funny things. But one of them does appear to have a lot of this reddish-orange material on it, as well as the kind of general white and gray. Earth's moon was formed as a result of a collision from a Mars-sized object when the planet was really young and really malleable. A bunch of stuff got spewed out into orbit, and that eventually coalesced into our own moon. Based on the appearance of these moons, I'm pretty sure at least the 4 that don't have the red stuff on them formed in a relatively similar way, though they didn't necessarily have to have formed from Mira itself. They could have been formed around another planet or formed loosely from a collision of 2 similar-sized objects, and just happened to get caught by Mira, because, I don't know, I could see a couple smaller moons being formed, but I'd be very surprised if Mira was able to maintain itself in general if it got hit by something so big to launch that gigantic moon out. There are at least a few different possibilities for what the color on the reddish moon could be. The first is that, like Mars, it has a bunch of iron visible on its surface, and that's getting oxidized and turned red, aka rust. Yeah, Mars is basically rust, which is kind of cool. And it could just be kind of a mini-Mars partway through that transformation, so that's why some of it's red and some of it isn't. Or it could be something more like Jupiter's moon Io, which might make a little more sense because it is a moon, and have heavy volcanic activity. I do personally think that at least part of the red stuff on the moon looks a lot like the distribution of volcanic flows, but at the same time it seems like the reddish stuff in some places is in higher areas as opposed to lower areas where you'd think lava flows would be, so I could really go either way on that. Last thing I want to talk about, though, is the big moon, because it seems like the designers took a few cues from our solar system when they were designing it, because a lot of this moon appears to be heavily inspired by the geography, again, of Mars. There are a few locations that I feel like might have been lifted directly from a surface map of it, the most important of which being that huge giant canyon system near the equator that stretches for a really long distance, which if you've ever looked at a picture of Mars, you might recognize as something being very, very similar to the Valles Marineris, the gigantic, uber-sized version of the Grand Canyon on a different planet. And that leads me to think of a very, very interesting theory. Don't take this nearly as seriously as the rest of the video, like all the real science stuff has ended already, and this is kind of just a last tangential conjecture before I close things off. But if this moon is so heavily inspired by Mars, could we actually treat it as an analog to Mars? That being something of about the same size and mass, that just kind of happens to be orbiting Mira as a moon instead of being its own planet. If we assume Mira is around the same size or a bit bigger than Earth, then this would actually make the system a double planet and a lot more similar to the Pluto system than anything near Earth. Pluto and its moon Charon are sometimes considered a double planet or double dwarf planet now, and have a bunch of other smaller moons that are orbiting the system, but technically orbiting both of them and not just one of them because the mass of the moon is so big compared to the planet that it's actually a pretty big fraction of it. This could be possible, and you could be looking at a system that's kind of an analog to Mars orbiting Earth and then having a bunch of other moons, but at the same time, all the other moons Pluto has are probably captured Kuiper Belt objects and not like things that are big enough to be round, but if you have an Earth and Mars, then they're also big enough to have strong enough gravity to have other round objects. So I'm actually pretty interested in this. It's also possible that it could just literally be Mars, but with a big enough atmosphere that it has one, but not the right kind to have rain that oxidizes all the iron. Or it could be Mars, but made out of the same Earth stuff that made the moon. I'm not really sure, but there are a lot of questions that can actually be answered about Mira, its surroundings, and its place in the universe, even if there are plenty more that have not been written yet, and I really hope we get an X2 to answer some of this stuff. So, I should probably go back to studying, and you should go back and wait for my next video, because until next time, this is Luxon, signing off.